go ahead and let me share my screen. I believe you can all see my screen. Alright, so I think we'll be starting now. So, but before we start, I just want to clarify some, let's say, a little bit of some things that we did in the last class. Clearly, we're going to work on one of the projects that I gave you guys yesterday. So, but before we start work on the project, I'd like to clarify something. I'd like to clarify some things, and one of them is we discussed about machine learning in the last class. Discussed about machine learning. So, but one thing I didn't tell you guys was that machine learning actually have different, let's say, tasks. So we can call them machine learning tasks. Machine learning tasks. So basically, I think the very popular ones we actually grouped into three. You have the supervised learning. You have the supervised learning. Then you have the unsupervised learning. You have the unsupervised learning. And then you have reinforcement learning. You have reinforcement learning. So this is what I didn't clarify. Now, in supervised learning is just basically you have a data set, and this data set contains, let's say, the variables that you are going to work in, things like the columns and the rest. But also you have one thing, which is the desired output. You have the desired output with you. But for unsupervised learning, you have the data, but you don't have it. Let me say no, there are no desired output. There's no desired output for unsupervised learning. So remember, supervised learning, each and every one of them have data, but then for supervised learning, there is a desired output, what you are trying to predict. Let's say if you are trying to predict salary, or you are working on just that will analyze salary of, let's say, a particular set of people, marketing, engineering department, and the rest. There's a desired output waiting already. But for unsupervised learning, there's no desired output. So the only thing you are doing is you are trying to classify, let's say, or trying to group them, or any kind of data, trying to group them into various classes based on their similarities. So, and this machine learning actually, when you come to supervised learning, you have what we call classification. You have what we call classification, and then you have regression. So what we did yesterday, what do we predicted what in the last class? Someone remind me where we were trying to predict in the last class. Hello? Can someone remind me what we were trying to predict in the last class? The project we worked on. No one. one, you can drop it in the chat.
We were trying to predict the survivors.
We're trying to predict survival. And Balogun, you're raising your hand. Balogun, the number of people who survive. We are trying to predict the survivor, the chance of survival for a given person on the data set. So our goal was either the person will survive, let me use S, or not survive. But instead of using S, I think survive, not survive was represented as 0, and survive was represented as 1, if I can remember. So this type of problem is classification problem. So classification problem has to do with when you have a category, things like category. We call this classification. Things like you have let's say cat, dog, and so. These are classification problems. So classification problems is just like a category. So in the case of the Titanic data set, either a person will not survive or the person will survive. As is a category. But regression problem is when you have, let's say, a continuous number. A continuous number is a regression problem. So an example would be probably salary, the salary of somebody, or another example would be, let's say, the price of a house. The price of a house is a regression problem because the number is continuous. The number is continuous. The number can be 1, 2, 3, 4, 5, so like that. 50, 80, 100, something like that. Yeah, it's a continuous number. So when you're dealing with supervised learning, you have, let's say, two scenarios. You have the classification problem and you have the regression problem. Classification has to do with like category. I'm giving you an example: 0, 1, or cat and dog, or no, yes, things like that. These are classification. While regression has to do with continuous number, or number that have values that are continuous. That's in this case we are talking about the output now. That's the y value. But for unsupervised, we'll be coming to this one later. Unsupervised, you have things like clustering, you have things like dimensionality reduction, you have association rules, and the rest. So we'll be coming to this one later. Our focus now is on the supervised learning aspect. So remember, supervised learning is, let's say, a kind of learning where the data that is given to you have, let's say, a desired output with it. So sometimes we call it, it has the label data with it. And it is grouped into two. You have the classification, where you are dealing with, let's say, a particular set of categories. Could be 0, 1, could be 1, 2, 3, depending on what you are trying to categorize. Then you have cat and dog and the rest. The regression now has to do with a continuous number. Could be salary, could be the price of a house, uh, anything that has to do with a, let's say, continuous number in that case. So the Titanic data set I worked on was based on classification. So the project that we are going to work on today is one of the projects that is and that is the one of which group. If I can, so what I did was actually, if I say I will be writing the code from in the class, it's going to take, let's say, a lot of time. So what I did was I already have the solution. So we'll go through it and then I'll be explaining the code and be running it at the same time. So let's go ahead and let's start. So the anime ratings project, that's the group that are working for that. I said that there's a company currently, they are trying to go into, uh, since everything is moving to the web, they want to venture into broadcasting most of their things on the web also. But your job now as a data scientist working for that company, your task is just to analyze the data and then you identify, let's say, important factors, and then you just build a model that will be able to predict the rating of an anime. So if you watch movies a lot, you know that movies have ratings. If you check online, if you check a particular movie, let's say movie ratings. If you check a particular movie, there's always a rating for it, and you can compare the rating to other movies and see how well people have been watching that particular movie, or the number of persons that have watched the movie, or the number of persons that are still watching the movie. So before we go into the project, let me there's a Python library I showed you guys in the last class, which is we said in sklearn. We use a model called logistic regression in the sklearn library, if you can recall, to train our Titanic dataset. So if we check, let's go to the sklearn now. Let's go to the sklearn in documentation. And I would advise each and every one of you to at least try and go through the documentation. The documentation gives you some information that probably we may actually not really cover everything in the class here. So but if you can go through it, it will be highly beneficial to you be able to understand. You can see sklearn has a lot of libraries. You can see you have classification library. So you have a library dedicated for classification problems. You can see identifying which category an object belongs to. You can see application will be spam detection, image recognition. You can see you have algorithms that you can use for classification. So we only use logistic regression, but you can see there's SVM, support vector machine. There's nearest neighbor, as K nearest neighbor. There's random forest, a lot. There's decision tree and the rest. You have classification here. Then you have regression problems. You can see predicting a continuous value attribute associated with an object. You can see there's drug response, stock price, and the rest. The algorithm is SVR. So some algorithms here, some algorithms in the classification, you also find them in the regression aspect, but there's a little bit of difference. You can see this SVM here, so vector machine. What you'll be importing here will be the classifier, but using SVM here in the regression, what you'll be importing will be the regressor. So this SVR, so support vector regression. You can see you have clustering here. So you have different, you can see dimensionality reduction, you have model selection and processing and the rest. If you select classification, you can see you have a lot of models that you can use in the classification. And if you recall, you can see we use logistic regression in the last class. So if you select logistic regression, it will give you some information about what the model is. You can see there's some theoretical background also to what the model actually is. And if you scroll down, you should see an example of how to actually implement the model. Where is it? Yeah, you can see from sklearn.linear model we import this radio regressor and we use it. You can see .fit video training like that. So I would advise everyone, you go through this is documentation. Documentation is very good. You go through it, you can see based on supervised learning. You can select any model here, you go through it, read more, and you're good to go. So let's go ahead and let's continue. So we discussed about the variables. For those that are not doing an anime rating project, these are the variables that we have in the dataset. There's a title, there's a media type, that's a format of publication, EPS, that's the number of episodes, and duration. So I think the dataset is in the drive, so you can, those that are not doing the anime project can also download it and actually go through it. Then there's the start year, that's the year they started what the air the either the movie or the episode. The finish year when they stop let me say publishing. Then description, you have watch, that's the number of users. that completed it, then watching, number of users that are still watching it, and the rating, and so the average rating, the votes, that's the number of votes that contributes to that rating. The studio, the genre, we know this, whether it is action, it's adventure, or any other thing. So in the last class, you recall, I told you guys that when you want to build a model, the first things that you do, you import dependencies. Those are the necessary libraries that you need for your modeling. And if you notice here, we can see libraries for reading and manipulating data. And the ones that you use frequently, like I told you, is NumPy. So we import NumPy as NP, we import Pandas as PD. Then the next set of libraries that you import are libraries for visualization. And like I told you, you import your Matplotlib as PLT, then you import your Seaborn as an SNS. So we set it. Then we go ahead and we import, this one should not be new to you also, our train test split. You recall what we said, we import it from the sklearn model selection. So if you recall what we are using it to do, we're using it to so that we can split our data set into a particular proportion, either 70 by 30 or 80 to 20%, based on what we decide or what we choose to do. Then now you can see linear regression model. We are importing, or we are going to look at a new library. In the previous class, the library we looked at was sklearn. Now in this class, the library we are going to look at is the start models. So if you want, you can copy this, or you can also check it online so that you can look at the documentation. You can see this is start models, and if you click on it, you can see this is the documentation. You can actually go to the documentation and you have some background or some information of how the model works and how you can actually use the model, which is something that each and every one of you will have to develop passion for, reading documentation. So that's that. So but we're going to just use it just like the way we use the sklearn model. There's no fancy in there. And then from sklearn metrics, remember this, we used this yesterday in the last class. In the metrics, we import, in the previous class we imported an accuracy score, but today you can see we imported a mean absolute error. All of these are also measurements for performance measurement, so that we can see how well our model is actually performing. So there's mean absolute error. We'll be going through how all of this works probably in one of our classes. There's a mean square error, and then there's the R2 score. So for those of us that have a little bit of background in mathematics, I think we'll have a little bit of understanding of how this works or what is actually used for. But for now, just know that this is used for performance and checking to see whether our model is performing well or not. Then the next step is to load our data set. So our data set is loaded. You can see pd.read_s and CSV. We did all of this in the last class, so this is not new to us. So we use pandas to read it, and then we assign it to a variable called an anime. Then we went through data overview. Now we said to display, we just want to see the first data set. That's the first 5 rows. So we say dot head. Remember, you can put a number in this. If you put 10, it's going to give you the first 10 values. Now remember, like the head, you can also put tail. You can also put tail to give you the last 4. You see, so you put tail is going to give us the last value, and you can also put a value in here with that 10 and to give us the last 10 values. Remember, so you can use dot head and you can use dot tail. So let's change it back to head. So we have these first 5 values that we have. So I put a little bit of information there. So these are some of the things that you're going to be doing. Once you do this, at least it will give us a little bit of background information, what you can actually see from this. And what we can see is, you can see the dataset contains information about different anime. Yeah, you can see where is it? Different anime. So you can see title, there's dragon, whatever, there's this, all of this. There are many anime seem to have a single episode only, which are movies. Yeah, if you look at, you can see EPS. Remember, EPS is the number of episodes, and you can see 11111. So some anime here have just one episode, and that will actually be movies. I think that was stated in the data variable. Yeah, in the variables, number of episodes, movies are considered one episode. So these are some information that you give about the dataset. So description seems to be missing in some anime. Yeah. So if you go to the description group, you can see NaN. NaN means not a number. So, but when you see that, just know that it is a missing value. So these are some information that you'll be given out when you are actually running a data science project. So you can see just from .head, we are able to get some information about. So just by applying head, we are able to get some information about our data set. So, and we put it down. Remember, why you see this is because you can see it's in markdown. I change it to code, and I can add something to it. If I change it back to markdown, I can run it and to just display as text. So this is one of the beauties of Jupyter Notebook. So you can put code, you can put text together, and it will actually come out well. Then checking the shape of the data set, we discussed this in the last one, so that's why I'm just brushing through them. So we said the shape will just tell us, you can see we have 6,523 animes with 15 attributes, that's 15 columns. So we put a little bit of info here. The data set contains information as 15 attributes, as 15 columns, and about 6,523 anime, which is here. We've used all these functions. Then .info, we discussed this already. You can see .info. From .info, you can also get some information which we've written down here. You can see there are 8 numeric. How do we know they are numeric? You can see int, float, int. You can see object. Anything object is a string. You can see a string. So we have about 2 objects here. 2 objects here, that's 4. Then 3 objects here, that's 7. So we have about 7 string, you can see, of object type. So from using .info. So these are just what you'll be doing. So the target variable is a rating of anime. Yeah, our target variable is this rating. This is what we are trying to predict. We're trying to predict the ratings. So given a particular anime, can we actually predict how much rating it's going to get? So I would say it's of float type. Yeah, you can see it's of type float 64. Then statistical summary, we did this too in the last class, where you just type the name of your dataset and .describe T. So T, we said is transpose, it's going to just change it. If you remove the T, the columns will now be up here. But when you put the T, you're asking it to transpose it to .t to just convert, so you have all the columns down. Then the name and the count and the rest are now up. So you can write a little bit of info from using .describe. So it's not just using the function itself, it's getting some information after you've applied the function. So you can see we've written down a little bit of something here. The anime ratings vary between 1.1 and 4.7. Now, how do we get that? You can see we come to where we have rating after the describe method. You can see here the mean value, that's the minimum value here, is 1.1, and the maximum value is 4.7. That's what we said. The anime ratings vary between 1.1 and 4.7. So So which suggests that what? That the anime were rated on a scale of 0 to 5. Because just by using describe, we are able to know that the ratings of the anime was on a scale of 0 to 5 just by looking at the minimum, which is 1.1, and the maximum, which is 4.7. So we know that yes, definitely it will be from 0 to 5. But from this, the minimum is 1.1. Definitely there was no anime that was rated 0, and 4.7 being the maximum, we can tell that there's also no anime that was actually awarded the 5 point completely. Then the general rating of an anime is 2.96. Yes, that one will come to the mean. You can see 2.96. That's what we're talking of the average. The average score of all the anime is about 2.96. So you can go through that. I'll be sending this notebook later. So if you notice that when you use describe here, it doesn't include the object variables. That's a string variable. It only include the numeric variables. So which are these? So, but if you wanted to include all the other variables, you can in the brackets here, the parentheses here, you write this include equals to all. So it will now include all the variables or all the columns, including the ones that are not of numeric values. But the difference now is that the ones that are not of numeric values, what you'll be looking at is this frequency column, this frequency here. That's the number of times, let's say, a particular value will appear. So you can see we say TV is the most occurring type of media just by doing this. And if you check, if you come to media type, you can see media type, you can see you have TV, and the frequency, that's FUE, the frequency here is about 2145. You can see, so it's the most occurring anime in this data set just by doing that. So the next thing we check if there are duplicate values. We type the name of our data set dot duplicated dot sum, and you can see it's 0 there. There are no duplicate values. So there are no duplicate values in the data set. Then checking for missing values. We've done this in the previous class. Remember, anime dot is na, then dot sum. You know why we do the dot sum? Because without the dot sum, we just have values of true, false, true, false, true, false. So dot sum will help you count it and then bring it out, let's say like in this kind of like a tabular form. So from here we can tell that okay, there are 27 values missing the media type, and there's 275 values missing in duration. In description we have this number of missing values. In both we have this number of missing values. So you can see there are missing values in media type, duration, description, and both columns. So these are some of the things that you also be doing. So the next thing is we want to start we want to treat, or want to start doing some analysis or even treating some missing values. So sometimes when we are trying to treat missing value, we don't want any changes to happen to, or any changes to occur in our original data set. We want our original data set to remain unchanged so that probably we can use it later on for something else or other further analysis. So what we do is that we create a copy. So to create a copy, you can see we created another variable anime copy, and then from our anime data itself we just say dot copy. So to copy this and assign it to the anime copy while retaining our original data set, which is the anime itself. So it is from the copy that we're now going to use to start running some analysis. So we copy that. So like I told you guys, EDA is what you are going to do use very well for analysis. So use this to kind of like see or make out, just check some data analysis on your data set. So the first ED that we are going to look at, you can see I've written a comment that creating a list of numeric columns. So if you notice in our data set we have some values that are numeric, that holds numeric values. Where is it? Where is it described? That holds numeric values, things like episode, duration, start year, watch, watching, rating, and vote. They are all numeric values. But others are not numeric, things like description. What else? Description, yeah, the genre is not numeric. So what we're trying to do is just to grab all the numeric values and assign it to a list. We've talked of list before, you know what a list is. So you can see from our anime copy, which is the copy we made, but it's the same data set. Then we use the function dot select d types. Select d types will d type means the data type. So which data type are we selecting? So we're asking it to select the data type. So if there's a function you don't really understand what it's doing, sometimes you can just come to Google and check. Let's look at select underscore d types. This d types and it's pandas. So sometimes you can go, you can see this is the documentation. This is documentation, a pi data documentation. So you can see pandas or data frame dot select underscore d types. You can see saying include equals to. So it takes two things. It takes include, the default value is none, and it takes an exclude, the default value is none. So you can actually read what it is. Where is the include? So include, you can see a selection of data types or string to be included. At least one of these parameters must be supplied. So you can actually go through the documentation and it give you a little bit of info. And also there are examples. You can see df.select d types include boolean. So it's only including the boolean. You can see that selected just the boolean. So if there's any function you don't understand what it's doing, you can check it. So this is what the select the d types is doing, selecting the type of data set. And from the include that we just finished, we're asking it to grab the numbers, that's the numeric values, using np.number. Then dot columns, we just grab all the columns. Then dot to list, it will convert the columns now to a list and then save everything in num columns. So if we run this, we're going to get this. And then we are removing this start here. So dot remove, you know what? If you want to remove values from a list, you use dot remove. So we are removing this start here column and this finish here column. Then the next thing we are doing here is we are creating what we call a heat map. We are creating a heat map. A heat map, you actually use it to check if there's any correlation between your data set. So okay, later on or in subsequent classes, we are going to go through this step by step. So today we just wanted to quickly go through the project and see what we can do. So from here, anime available as web, we're going to come through all of that. So like I told you, you are going to do visualization. At least visualization gives you an idea of or some hidden things or insights in your data set. So one of the visualization, like in the previous class, we used what visualization? Okay, we used the count plot from Seaborn. So now you know how to use the Seaborn because we used it in the last class. So the plot we used there was count plot, but in this case, the plot we are going to use is the box plot. So this is the box plot. So how we do it is the same thing, just like the way we did SNN dot count plot. Then we give it the data and we give it the values that you should plot. It's the same thing we're actually doing here. So the only difference or something we didn't use in the last class is this figure. So this figure is just telling you the size, just saying the size of this of the let's say the image you had here, which we are still going to go through it when we are covering matplotlib in details. So instead of count plot like we did in the last last class, we are using box plot now. Then we give it the data. So you can see data equals to, we are giving it our data that we just copied. We are asking it that in the x-axis you should put media type, in the x-axis, and in the y-axis you should plot the rating. So if you actually do that, then you can see. And then just from this, you can see we said anime under the genre of drama. There is drama. There is drama here. Is movies, TV special, DVD special, TV, web, and this OVR, music, video, and others. As the highest in general wide genre of comedy. Why is it not here? Okay, but let's just go ahead. The box plot now. The middle line that you see here, the middle line tells you. So for those that have a little bit of background in math, the middle line that you see in your box plot represent the median, right? The median. So the box plot actually even gives you the full. Sorry. Okay. Okay, let's continue. So let me just type box plot real quick here so that we can see what it is. Okay, let me see box plot interpretation. So let me select this. So if you can see this, let me see the image. If we can get a better image for that. Good. So if you can see this, you can see this is a box plot. So the middle line there represent the median. So then this one represent the lower quartile. That's Q1. So if you can recall some of the maths we did in secondary school back then you have the upper quarter. Then the upper line here represent the maximum value. Then the lower line here represent the minimum value. So, but the distance from here to here gives you the interquartile range. Don't worry, later on we'll be going in full details of what all of this actually means. So if we look at it, we can check how many or which media type actually has the highest rating in this case. From the box plot, can we pick or can we select any media type that actually has the highest rating? And if
TV.
yeah, if I can tell, yeah, TV is actually having the highest rating here because you can see the maximum points. Then if we look at the median, we can actually tell the median. If I trace this value back to this place, I think the median is about 3 point something. That's for the TV. Then from here we can tell the one that actually has the lowest rating. And can I say is the one that has the lowest rating will be what? I think is web. You can see the minimum. You can see this is minimum value. So it's the one that has the lowest value or the lowest rating in this case. So what else? So you can go through the box plot and you can bring out some actually insightful information. Your background is a little bit type. It's better you type in the chat box. Azina, please can you mute yourself? Okay, thank you. So you can go through the box plot and you can get some insightful information about it. So the next one we are comparing the junior with the rating as well. So if you plot it, we can also check. So you can tell which has the maximum. You can tell the median of each and every one here. think the inside rated anime under the genre of drama and romance have higher viewership in general. So let me see. There is drama. Okay, this is drama. So you can see drama actually has the highest here, and followed by romance.
Hello, sir.
Having like the highest rating in this case. Yeah, Ahmed.
Yes, sir. The statement that is written before the statement written after the code,
Yes,
that anime under the genre of drama and
yeah,
romance, that's higher what genre. Is
yeah.
for the code block on after it, not the one before.
The code block where?
After that statement. And
Yes,
that
this.
statement is referring to the diagram after the diagram
Yeah, yeah,
below.
yeah. It's referring to this.
No, the one below.
That the one below it.
This, this one is for viewership.
Okay, okay, okay. Yeah, yeah. Sorry. Okay, I think that was okay. Yeah. So yeah, yeah. It's actually describing the one below it. Yeah. Thank you for that. So you can use your box plug to actually get some very good insight to your data set. So here we are checking the genre versus the watch. So you can see 0 to about 4,000. So this one is as the number of person that have watched, and they have different and hence you can actually tell that you can see drama is very high. You can see and romance is very high here. So people you can tell that okay, probably people prefer watching drama and then movies that are romantic nature. And then I think comedy here is low, and comedy has the lowest. And then you follow by the rest, so you can actually use that to get some very good information. So looking at this one, comparing with watching, that's people. Remember, watching is people that are still watching it or that are currently watching it. And I think drama and romance is still beating the chart. And then comedy, you can see comedy is very low in this case. And then we are comparing media type with duration. Comparing media type with duration, and I think if you compare the media type, you have duration here. That's duration. That will be how long the movie actually takes. How long is it? 1 hour? Is it 30 minutes? Is it like that? So I think if you look at movies, yeah, movies have longer hours. You can see this about. So it's in minutes. Yeah, this about close to 70 minutes. This for movies. And then you have followed by TV specials, and then I think what else here? This OVA. Can't really tell what OVA is, but really. So once you are done with that, the next step is now how do you treat those missing values? Remember, when we check is any media type had some missing values, duration, and also description. So how do we set to all those missing values? So if you look at the first thing we do is for the media type, we can actually tell what media type is in this case. That's for where there are missing values. We can't really tell what values is supposed to be there. We can't tell whether it is TV. We can't tell whether it is what. We can't tell whether it is web or it is music or it is. Yeah. So what we can do is just fill down with order because we have order here. That's maybe like orders. So the ones that we are not really specific or we don't know what it is. So that's what we did here. So remember we use this. So we take our data dot media type. Remember we did this. We did this in the last class that you can access different variables. You can access the column using different method. You can use the square method. Remember, you can use the bracket method where you just type the name of the column, media type. So if you hit enter, you can see to give you this, and at the same time you can use the dot sign. And to still give you the same thing. We discussed this in the last class. So that's what we just did there. And then we use fill NA. We discussed this the last class. Fill NA, that's fill the empty values with what? With order, like we said. And then remember, we use in place true. That is, you should replace those values if you get that. Now, but for duration and vote, remember duration is also have empty values, and vote also have empty values. So for duration and vote, what we're going to do is, let me create two cells here. What we're going to do is, remember that duration, movies have a different duration, TV have different duration, DVD special have different duration, TV also have different duration, and web has different duration. So you cannot just go in and then just fill the empty values with something. Remember in the last class we filled the empty values with the average, with the average age. But in this case, each and every aspect they have their own duration. And also the vote. The vote for, do we plotted anything on vote? I'm not sure if we plotted anything on vote. But the vote you may get for let's say a movie will be different from the vote you get for comedy, TV, or DV special. So how do you settle that? So what we'll do is we'll tell we'll build a code that will go through our data set. In these missing values, where is duration? In these missing values, it's going to group them. It's going to check first if those missing values belong to this particular type, media type. So it will go through it. Let's say out of 275, maybe there are 10 empty values that actually belongs to TV. There is going to fill it with the values of that we're going to design for TV. And if out of that maybe 20 are from web, it's going to go through it and actually fill only the ones that belong to web. So the way we do that, we use a function in pandas. We use the function called group by. So let me go ahead and let me use it here so that you have an idea of what it does. So all I have to do is, let me copy my data. So dot, and I'm going to say dot. So what I'm going to use, I'm going to say dot group by, and in group by, let me select media type. Yeah, let me go ahead and let me select media type. So media type, and then let's grab the duration. Let's grab the duration, and then let's look at the mean value. So look at what I've done. So the name of the data type in dot group by. So I'm asking it to group my data by this column. That's group it by the media type. Now after grouping it by the media type, remember the square bracket, use the square bracket to grab a value. So we're asking it, after grouping by media type, grab the duration and then give us the mean. So let me run this. What's the problem? Okay, I didn't put B in the by. So can you see what it has done? So dot group by the media, group it by the media type. It can help us get the duration and then give us the mean. So can you see what it has done? So you can see DVD special, this is the mean of its own duration. Movies, this is the mean of its own duration. Now you can see that the values are different. Music, for music video, this is the mean of its own duration. Now you can see that it is very much different. So that's exactly what we are doing in this code here. So what we are doing is we are grabbing the duration and we are filling the empty values now with their own unique values. So the fill NA value equals to group by, but this case now we are grouping by the general, and the media type. Then when we group by that, then we grab the duration and we transform or we fill it by the median. So today now, in this case, we are filling it by the median. And it's the same thing we did for the vote. So first of all, group it by the genre and the media type. Then we'll grab the vote and then we fill the empty values with the median. So remember, this is just what group by is doing. Group by, grab a value and the duration. Now you can actually put multiple values here to group by, so depending on the situation. But if it is one, we just type in there. If it is more than one, you have to put it in a square bracket. So rather, let me just put it in a different cell. So if it's more than one, let's say we want media and something else. So let me erase it first. If it's more than one, you use a square bracket. So let me use the one that is here, general, comma, and media type. And the media type. So we grab it and then we grab the duration and then we find the name. So let's see, can you see what it has done? So you can see first of all group by the group by the genre. So you can see whether it is action, science fiction, or name. And then you have the media type. You can see. So in the action you have DVD, movies, music, OVA, and other. In the science fiction you have OVA, other, TV, and TV special. Just like that. And then you grab the duration and then you give us the name. So it's the same thing we just did here. But in this case now, we are filling the empty values with the median. So once we've done that, you can see, we then check is NA again. You can see virtually all the missing values have been filled up, except this description. And the duration, we still have 8 values missing here. So maybe there's a reason why these 8 values are not filled up. Probably there is no general for, let's say, those missing 8 values, or they are not in a specific media type. So what we can do is just to fill the remaining one with we group it by general, then we just grab only the direction and then we transform it by filling it with the empty values. So that's just what we did there. And then we check the empty values. Now it's only description that is left out, that is not used. So the next thing we do is feature engineering. So what feature engineering is just probably trying to create another column. So we say create a new column, years running, by taking the difference. So it's just like what feature engineering is. Let me give you an example. For example, you have a data set, and the data set have let's say the year a particular person was employed in a particular company and the year the person stopped working. So if you want to get how many years the person have worked in the company, is to take the year the person stopped working, right? And then subtract it from the year the person started working, and you have a new column, which is the number of years the person have worked in the company. So it's exactly what we are doing here. We are creating a new column called years running. So years running, and then we are taking the finished year minus the starting year. Or just like another example would be, given a data set, you have the person's birthday, the person's birth year. You have the person's birth year, but you want to know how old the person is. So you can create a new column that has, let's say, the age of the person. Then in this case, what will you do? You take the current year minus the person's birth year, and the value that you get will actually be the person's will actually be the person's age. So that's exactly what we are doing here. So we are grabbing the finish year minus the start year. So you know how we grab values using square brackets. And then whatever result we get, we assign it to a variable, and that variable will be a column in this data set. Then you can see the drop. We talked about drop in the last class. The drop is dropping the since we now have this one, just like since you now have the person's age, or you have the year the person has been working in the company, then you don't need these other ones again. You don't need the start here and the finish here anymore. So we can go ahead and drop them. So that's what we just did. So after dropping it, we check the head of the data again and see what we actually have. Then the next thing we are dropping is we are dropping title and description. Why? Because title and description will not actually play any role in the rating of that's in this case. Now we are assuming that title and description will not play any role in the prediction of our data set. So that's what we are doing. So we did this too in the last class. So we are dropping